So you can see here, this is the new emulator, the TI SmartView CE emulator, and you would say, hang on a minute, it doesn't look any different. Well, yes, that's because it's in the TI-84 mode. This will be a free upgrade. We've got a beta version at the moment that we're using, but this will be a free upgrade for you later in the year when the handheld becomes available as well. So if I switch now to the colour version, wow, look at that. I have to say, I'll get very excited about this. We now have colour, we now have better pixel resolution, and we now have a bigger screen. So quite an impressive sight. Wouldn't you agree, Brian? Brian's not there. Daisy's there, I'm sure. Okay, so we'll do a graph. We'll do a cubic. So nothing has too much difference here at the moment with the cubic. But we can see that now, rather than just having a line that will be shown, we can see that the line will now be blue when it's drawn. And if I graph that, we have a beautiful blue cubic line that's drawn. And really at the moment there's no advantages of that over any other, even on the 84, unless we're going to add more lines to it or do extra things to it. So at the moment it looks pretty. I'm just going to change the window slightly to make it look a bit bigger. -5 to 5. Alright, so we can see our cubic here. But it only really comes into its own when we add other lines. In the past we would make it bold or dotted or maybe have that ball that moves along the line. But now if we want to add another line, many different lines we can add. This time I think I'm going to show off a few of the things that have been around for a little while on the operating system, the 84, is the quick keys on the top. So in F1 we have much quicker stuff on fractions, in F2 to do with functions, F3 to do with matrices, and the variables of Y in F4. So we're going to go into functions and I'm going to graph the derivative number 3. And we're going to differentiate it with respect to x of this cubic. Now to get that we used to be able to go into vars, but much quicker to go into alpha F4. We're going to differentiate it with respect to y, and rather than the specific point, we're going to do it for any point. So for every point, so x equals x. And then when we produce our graph, and we could talk to the students before we press graph on this, what it's going to look like. So this cubic will then draw me.
Oh, I'm predicting a parabola.
There we go. Well done, Brian. Go to the top of the class. There's a lovely little parabola being drawn. The functionalities are all exactly the same as before. The nice thing as well, if we were doing something like intersect, is that we can now, the students not have to worry too much. They can see much easier which line is which now. So the blue one, yep, that's the one I want. Especially if there's more than two, obviously, the red one. And if I wanted to find this value here, well, it's close to -1.5. So rather than moving the cursor, let's just type in -1.5. And it gives me the intersect point. Very nicely done. And we could also, don't forget that those values are available in its short-term memory. If we needed to use those values later, we have a value stored in here. We could store that as a different letter because every time that we do a calculation in the graph, the x value gets wiped over, so we store it as a letter. And now that number, that was the intersect, is now stored as the variable a. And if we then, for example, wanted to find the area of the graph, we need to go to the graph first. That would help us. Can't find it. We could do it there, but it wouldn't actually give us the area. Second calc, the area. We could now find it perhaps of the blue curve between that value there. So between A and, let's say, the origin, 0. And there is a nice shading of the area. Brian, is there anything at this point that you'd like to add to that?
I know I've got students who are pretty happy to see that sort of stuff.
Yep.
And just another one that I often start on with just some of the lovely colour and shading. An activity that I've done across the years, or crops from year 7 onwards, is drawing functions and making pictures out of them. You know, say parabolas as the bottom of a boat and sine curves as the ocean. that activity to now revisit is just going to be absolutely awesome with the
fantastic different that you could include. Yeah, it'd be lovely. All right, so I'm going to now move on to the other second, another second thing that I find very cooler now about the colour version is the fact that we can now put images onto it. And I'm just going to reset all this to save me having to delete things. Just reset all the RAM. Just reset everything for me. Okay. And now there are images stored on this calculator. So in the graphing screen at the moment, nothing's any different. But we now have images that either we can download, and I'll show you that later, or images that are already on the calculator. And we'll use one that's already on the calculator at the moment. So to find those, they're in format. So there's a couple of other ways, but format for now will allow us to get to it. And here you can see that there's background. And it's the background that we're going to change. I scroll up rather than down as I can't be bothered. And there are 5 images already pre-installed on the handheld and on the software. A nice bridge somewhere, a stairs of a playground, a flower, a water fountain, and a starfish. So we're going to focus on the water bubbler, and as soon as we select that one and now go into graph, we can now see that the image is overlaid onto the axes. Really nice touch, and now allows us for either the students to use these images or Google images like Brian will show you later, or their own images and put extra functionality and relevance to what the mathematics is that they're doing. To make this a bit easier for me, I'm just going to move this axis, and there's no place I could move it to where the maximum is, but for me I'm going to move it over to the base of the tap. And also, because this is a real picture, I'm not sure if that's the right language, so there you go. But it is proportional, and it is to scale. We need to make sure these axes are to scale. So to do that, make sure that we go into zoom, and we go zoom square. Rather than being a rectangular window, rather than 10 by 10, it's now made all these dashes the same. And we're going to move it across. 1, 2, 3, 4, 5, 6, 7, 8. We're going to move it to the left by 8 and down by 2. Nice question to ask the kids. How are we going to move this axis to the left by 8 and down by 2? Well, we could go to the chat window, but I'll do it. So for everybody else, we are transposing it or translating it to the left, so therefore we are going to go and insert an 8 because we're going to add 8 to it. And I could go to the end of the number, so I'm going to do it here instead. 8 added here. Keep the scale the same, I'm not worried about that. And we're going to move it 2 down. So to move it 2 down, again, is actually adding 2. And second insert, add 2 to this one. Has he done it right? Yes, beautiful. Just again to show off the colour functionality, these axes are a bit plain now, and hopefully the kids will have the excitement of changing the colours, but that won't become the focus of the lesson. We'll see. But into format, we can change the axes as well. I'm going to go down to choose the axes, and this time I'm going to choose a colour that perhaps it won't be one of my lines. So there we can see the axes potentially much clearer. Sorry about this, I should make it a bit bigger for you. I have to shut this down early, and there we go. Alright, now again, something that's been around in the Inspire for a while but is new to the colour CE is the fact that we can now plot some points on here and do regression by plotting points. So to do that, we're going to go into Stat, across to Calculate. These functionalities aren't any different. We can either scroll down to the bottom or scroll up to the bottom. And there are 2 new sections that have been on the Inspire for a while but are new to this calculator, to the 84. That is Quick Plot and Fit, which we're going to use now, and Manual Fit, which I'll show you later. So we're going to choose E. What that allows us to do is to drop some points. As it says here, it's going to drop some points. So I'm just going to scroll across. There's a bit of a lag when I use the software. Right, even more lag. What I normally end up doing is shooting off the screen on this one.
You'll hold the button down, or hit it a dozen times, next thing it'll fly off the screen.
It'll be over the neighbour.
Yeah.
All right, so normally this works a bit quicker, and definitely on the handheld it works quicker. Like I said, this is the trial version of the software, so hopefully by the time that this is available to you. So I'm going to drop a point there. No, it's not going to do it. So I'm not going to go too much, I don't think. I think it's going to take far too long for me on this. Maybe it's the WebEx is also slowing it down. When I did it earlier, it was working a lot.
Yeah, generally the software does seem to go faster in the handhelds, and the students fly with that. But cripes, the emulator is just such a useful thing to have. I know in my classroom I have the luxury of interactive whiteboards, and so I've got the 1.5-meter tall calculator up the front of the classroom, and it's connected to the interactive board. So you press the button on the whiteboard, and she works.
I also think I didn't have enough patience, Brian. If I actually held the arrow down for a bit longer, it started to jump across quite nicely. So I was lacking patience. Again, a nice thing to talk to the students about is actually how many points do we have to put on there. Nice discussion for the students to have about which is better, how many do we need. So I think we're going to
maybe three is an absolute minimum. But but yes, a good discussion.
Yeah, thanks, Brian. And now here, obviously, this is the handheld. We'd see this tab above F5 because we're using the software. It looks a bit weird, but this is F5, so we're going to press F5 now. We're going to fit the equation. What equation do we want to fit? We're going to fit a quadratic, number 3, excuse me. And there we go. Obviously, the points that I chose. And again, a really nice conversation to have with the students, get them to share their screens. Why did mine go up so high, whereas I know for a fact that if I chose that point and perhaps a point at the top and this point, it wouldn't replicate that. Really nice, again, really rich discussion to have with the kids, and the advantage of definitely technology and graphics calculator is to achieve that very quickly, and then it's the discussion where the real learning occurs. So we're going to, again, F5 that to store it. We'll store the information in list 1 and list 2, so dump those points into there for me. I'll set up the stat plot automatically, and it'll also store the regression equation in Y1. I can change any of those if I want to, so I'm happy with all that information. Not if I go too far, I'm not. Nothing's really any different on here, but we can see that in Y equals, the equation has now been dumped into it. In stat plot, it's been turned on, and in statistics, the information of those 3 points is now in here. And like I said, if I did it to more detail, then we would get a better match. Don't need to do more than 3 points, but definitely spread those points out. I use the analogy of talking to kids about the accuracy of a pistol over a rifle. That's not a good analogy now, thinking about it, but in the old days, that was the analogy I used to use. Anything else you'd like to add to that, Brian?
Well, John, if you're talking parabolas, I mean, a drink of water is all very nice, but you did mention you went to the footy on the weekend.
I did go to the footy, yeah, I did.
Yeah, I prefer to think of footballs.
Okay. Well, you've led me nicely into it, and I'll show it quickly. What you can also do is take your own images. Thanks, Brian. It's as if we planned this. And here's some images
like that, yeah.
ready. Yeah. And this one here is an image of a video that I took of my boys playing footy, and I've just paused it by my iPad with the ball up at its peak, and then I've just taken a photo of that on my iPad and then emailed it to myself. So really simple to put this onto the software and equally onto the handheld exactly the same.
Just while that's opening up, John, just in itself a really interesting exercise. Send kids around the school with cameras or with their phones to just take photos of things that you think, or that they think, will produce interesting mathematical graphs. It's really wonderful what you get back. You'll get, of course, parabolas, you'll get straight lines, you get ramps and so forth. I've had kids, I teach in a P12 school, and I've had kids going over to the primary play equipment and looking at a spiral-type jungle gym thing that the primary kids play on, and from the angle that they photographed it, they were then subsequently able to fit a sine curve.
Yep,
which
lovely.
I thought was quite creative. Yeah.
Yep, that's fantastic. And obviously we've had that for a while at ease with the iPad app, for the TI-Inspire iPad app, but and to some extent on the Inspire, but this is the first time we'll be able to have it on the 84. So this is fantastic. And I'm going to show you how to do it on the Smart View, but to do it on the handheld is exactly the same. There's a new piece of software on the TI website, and a new updated TI Connect called TI Connected CE. That looks like this. And if you look, you can see that my calculators, I have two calculators at the moment, connected to my computer. And we'll do it exactly the same with these handhelds. So, but I'm not going to use the handhelds for now. I'm going to use the emulator. So I find my photo. Here it is. We'll use this one here. And I literally just drag it and drop it across. Be careful where you want to save that image. At the moment, they've got images in 1 to 5, so I'll change where I save that. I'll save it into 6. You can send that image across for me. And when it's done that,
nice and sweet, hey?
click. There we go. This poor computer. Oh, it's working overtime.
John, I find it really interesting that, despite, the various software packages that can do this sort of stuff and put images and graphs together, students tend to really respond to the fact that this is on their calculator, it's on their handheld, the thing that they use in their maths classes. And to them, I think it really helps build the connections.
Yeah, and there's definitely a much more ownership of what they found, and not only ownership but also an understanding of what the maths is telling them. I think when they've done it in textbooks, they go, oh yeah, that's okay, I sort of get it. When they see it in pictures, they go, yeah, I sort of get it. But when it's their images and they experience that kicking of that footy, they can actually really go, yeah, I understand what was going on at that moment. So you can see that there is the image. It's not the best photo that I've taken, and it hasn't transferred well, but we can see that there, you can get the idea, and there again, we could actually plot a curve between one of my son's feet, the ball here, and my other son's feet, and do some really beautiful maths with that quadratic that gets produced.